Hello students, we want to see a situation whereby we will be combining linear sequence and geometric sequence together. Now let's look at this question. The fifth, ninth and 16th terms of a linear sequence AP are consecutive terms of an exponential sequence GP. So it means that when you are having the fifth term of the AP is equal to the fifth term, the ninth term and the 16th term of the AP is equal to first three terms of a GP. So that three consecutive terms of a GP. So if this one is the n term, then this one is n plus 1, this is n plus 2 of a GP. So they now say that 1a, find the common difference of the linear sequence in terms of the first term. So you are told to look for the common difference of the linear sequence in terms of the first term. Then B, show that the 25th, 21st, 37th term and the 67th terms of the linear sequence are consecutive terms of an exponential sequence whose common ratio is 7/4. Now, to be able to do this, we know that we are given that in the AP, the fifth term is equal to the nth term of the GP. The ninth term is equal to the n plus 1th term. Then the 16th term is equal to the n plus 2 term. You can see that this if you look at these are consecutive numbers. N plus 1 is n plus 1, n plus 2 is this. So these are the consecutive terms of the GP. So these are the terms of the AP that are equal to the GP. Now, if you look at it, now you have for the AP, you are going to use n into bracket a plus n minus 1d. So, and you are told that the fifth term, we don't know the value actually, but you want to get an equation for the fifth term. The fifth term is equal to a plus n here is for 5 minus 1d. So that means a plus 4d is the fifth term. Then you are given the ninth term. The ninth term again, you try to get it in form of the formula like that. So the ninth term is what? A plus 9 minus 1d. 9 minus 1 is what? 8d. So the formula for the ninth term here is what? A plus 8d. Then you have the 16th term. So the 16th term will be a plus 16 minus 1d. So a plus 15d will be the 16th term. So the fifth term here is a plus 4d. Ninth term is a plus 8d. And 16th term is a plus 15d. Now this AP now forms consecutive numbers in a GP. That means numbers that followed each other. So assuming this is the GP, the first one is a plus 4d, followed by a plus 8d, followed by a plus 15d. This one, if I'm writing, if to say this is a particular figure, this figure, and this figure forms consecutive numbers in a GP. So I'm going to write it as a formula like this. So the first one is a plus 4d, second one is a plus 8d, and third one is what? A plus 15d. So this is how these three numbers followed each other in a GP. Now, if I want to get the common ratio from here says that we are going to divide the one at the back by the one in the front. So if I divide 8 plus 8d by a plus 4d, it will give me the common ratio. Also, if I divide this 15 plus 5, a plus 15d by a plus 8d, it will give me the common ratio. So this and this are equal. So since they are equal, I'm going to equate them. So a plus 8d over a plus 4d will give us the same answer as a plus 15d over a plus 8d. So I'm going to cross multiply these two ratios. These are the common ratios. I will cross multiply this times this, a plus 8d times a plus 8d, then is equal to, this is a plus 15d times a plus 4d. So we will now try to expand. So that means a times a will give us a square. A times plus 8d is what? 8ad. 8d times a will give us 8ad. 8d times 8d will give us 64d square. Then this one also. So I'm going to expand also. A times a is what? A square. A times 4d is what? 4ad. 15d times a is what? 15ad. 15d times 4d is what? 60d square. So these two are equal. So a square is plus 8ad plus 8ad will give us 16ad plus 64d square is equal to a square plus 4ad plus 4ad is what? 19ad plus 60d square. So now I'm going to now equate it. So I bring this a square to this side. I'm having a square minus a square, then 16ad. This 19ad, I'll bring it here. It will now be minus 14ad plus this 64d square. Then I'll bring this one here also to be what? This plus here. When it comes here, now turn to minus 60d square is equal to 0. So a square minus a square is equal to what? 0. 16ad minus 19ad is equal to what? Minus 3ad. 64d square minus 60d square is give us plus 4d square is equal to 0. So from here, I'm going to bring this minus 3ad to this side. If I bring it to this side, I'm having 3ad. This is minus 3ad. When it comes here, now turn to plus 3ad. So to get the value for d, I'm going to divide both sides by 4d. So when I divide both sides by 4d, so 4 cancel 4. D here will cancel 1d. I'm left with 1d here is equal to 4ad divided by 4d. D cancel d. We have 3a over 4. So the value for common difference here, the question said that find the common difference of the linear sequence in terms of the first term. So the common difference, which is z, in terms of the first term is what? 3a over 4. Now the question now says that show that the 21st, 37th and 65th terms of the linear sequence are consecutive terms of an exponential sequence whose common ratio is what? 7 over 4. So now assuming, let's try to get the value in terms of the nth term. If you are talking about that of the sum, the nth term of a linear sequence, nth term of a linear sequence, you are going to look for Tn is equal to a plus n minus 1d. So now if I'm to get the 21st term, so the 21st term is what? A plus 21 minus 1d, which is what? A plus 20d. So if I now, we have been able to look for the value for d to be 3a over 4. Let me substitute 3a over 4 here. So when you substitute 3a over 4, so 2 here 1, 2 here 5. Happy 4 here 1, 4 here 5. 5 times 3a will give us 15a. So you now have a plus 15a. When you have a plus 15a, which will give you 16a. So that's the 21st term. Then let's look at the 37th term. So for 37th term, so that means you are still going to substitute here. 37th term will now be equal to a plus 37 minus 1d. So 37 minus 1 is 36d. So we've got the value for a to be what? 3a over 4. Substitute. So 4 here 1, 4 here 9. 9 times 3a will give us 27a. So if that gives you 27a, so a plus 27a will give us what? 28a. So that means the 37th term is what? 28a. Then look for the 65th term. So that means I'm going to substitute into the formula here also. When you substitute a plus 65 minus 1 d, 65 minus 1 is what? 64d. So if we now substitute the value for d, which is 3a over 4, so 4 here 1, 4 in here is what? 4 in 64 is what? 16. So 16 times 3a will give us 48a. A plus 48a will give us 49a. So that gives you 49a. Now, if the values you've got for the 21st term to be 16a, the 37th term to be 28a, and 65th term to be 49a. So if this is now the consecutive terms of a GP, so they now said that what? So they now said that show that the 25th, 21st, 37th, and the 65th terms of the linear sequence are consecutive terms of an exponential sequence whose common ratio is 7 over 4. So it means that these ones, if they are consecutive terms of a GP, so that means if you look for the common ratio, it should give us 7 over 4. So common ratio here, the one at the back divided by the one in front, 28a divided by 16a. So a cancel a, 4 here 7, 4 here for making 7 over 4. Also, if you 49a divided by 28a, so here a cancel a, 7 here 7, 7 here is what? 4. You can see that they gave us the same answer. Now let's look at the work practice. Number 1, the first and the second terms of an exponential sequence GP are respectively the first and third terms of a linear sequence. The fourth term of the linear sequence is 10, and the sum of the first 5 terms is 60. Find A, the first 5 terms of the linear sequence, and the sum of the first n terms. Then B, the sum of the first n terms of the exponential sequence. C, the limit of sum of the n term for large value of n. So that means you have to look for the sum to infinity. Then number 2, the 3 consecutive terms of an exponential sequence GP are the second, third, and the 6th terms of a linear sequence. Find the common ratio of the exponential sequence. So please ensure you like, subscribe, and comment on this video. Thank you.